Now we're going to talk about the sum and difference of two cubes as we go through all the different factoring strategies that you can implement. All right, so let's try multiplying and obtaining one first so that you can kind of see how it comes to be. All right, so here are a binomial times a trinomial, and if we multiply these out, I'm going to show you the two most common methods. One is the vertical method, where you would multiply like you did in elementary school. So you start in the bottom right. 2 times 4 is 8. Then you sort of go catty corner. So 2 times minus 2x is minus 4x. 2 times x squared is 2x squared. Then you skip a spot. So x times plus 4 is plus 4x. X times minus 2x is minus 2x squared. And x times x squared is x cubed. And these fall out, and you have x cubed plus 8. All right. The other way to do it is x plus 2, or common ways. I've seen something called the box method, and I have students who use that, but I'm just kind of like, okay. So we're going to just stick with these two. Now, so you cannot use the FOIL method on this particular type because the FOIL method stands for first, outside, inside, last, and there is no mention of this middle term right there at all, so it would skip it. Okay, so the FOIL method only works for a binomial times a binomial. This repeated distributive property, the x times all of these and then the 2 times all of these, that works on any size. And so does a vertical method. You get the same answer. So we're going to take the x and multiply it by everybody down there. X times x squared is x cubed. X times minus 2x is minus 2x squared. X times 4 is 4x. Then we're going to multiply by the 2. 2 times x squared is 2x squared. 2 times minus 2x is minus 4x. 2 times 4 is 8. Told you the answer. And these fall out, right? I have to admit that when they get to be trinomials and stuff, I use the vertical method because I feel like it kind of makes more sense to me working down like that as opposed to sideways. You use whatever method you feel that you are more accurate at and that your teacher will let you use. Okay? Now, regardless, you see how these middle pieces cancel each other out and you just end up with the two end parts, right? Now, let's look at something for just a second. So this x cubed is a cube. 8 is a cube. It's actually 2 cubed. So can you see that if you took the cubed root of these, kind of like we did the square root when we were talking about squares, if you took the cubed root of 8, you would get this 2 right there. And if you took the cubed root of x cubed, you would get this x right here. And then this plus is the same sign as right there. So the little binomial, you can see pretty straightforward where it comes from. It comes from the cubed roots of the cubes, right? This long trinomial, that's another story entirely. Okay, so let's see if we can practice on how that would happen. Okay, so if we had x cubed plus 8, let's say we started that way, and they asked me to factor it, right? I'm gonna say to you the whole list of it. Okay, besides we're skipping the part about is there anything in common to factor out right now. So I always say, show me the cubes. Well, x clearly has a cube on it, okay? But there's no cube on 8, right? But if I made it look like 2 cubed, then you would see the cubes. So the x is cubed and the 2 is cubed. So then what you do is you identify the cubes, then you drop the cubes or cube root it, however you want to say it. Here's an x, here's a 2. So you drop the cubes or cube root it. Now we're going to build this really long trinomial. And the way the pattern goes, and it's just a pattern that people observed over a period of time, and it's kind of weird, but we can do this, right? Is you take the term in the front and you square it, and you put it in the front. It has a few similarities to the difference in sum of two cubes doesn't factor. let me back that up. The difference of two squares, it has a few similarities too, and the sum of two squares does not factor. All right, you take the term in the back, which is 2, you square it. Okay, 2 squared is 4, goes back here. All right, if you want to, you can say, I take the 2 and I square it. All right, and then we can make it be a 4. You take the front times the back without paying attention to that, whether it's a plus or minus right there. I just want the front value and the back value. That would be 2 times x is 2x. And you build all the pieces, and then you worry about what's plus and what's minus. All right, so if this is a plus, this alternates. Okay, this is the opposite. They always alternate. And this one is always, you can almost read that, always positive. So that one's always going to be a positive. This front one right here depends on what the other one was that's the opposite. You will sometimes have people tell you this is the SOAP method. Okay, S stands for same. So this sign and this one are the same. All right. This sign and this sign are the opposite. That goes with the O. And this sign is always positive. So here's same, opposite, always positive. All right. Now, if you didn't miss anything that was in common to factor out, and if you generated these pieces in the trinomial accurately, like you didn't square 2 and come up with 6 or something, okay, then this trinomial down here does not factor any further, right? Because you would go, well, what multiplies to 4 and adds to 2? No. Okay. Now, so let's do another one. What if it was x cubed minus 8? Okay, first you identify or show the cubes. Some of y'all can do the cube roots in your head. Some of you need to show me the parts, all right? So whatever makes you more accurate. Like I keep saying, slow and right is better than fast and wrong. Okay, then you drop the cubes. So here's an x, here's the 2. And since all you're doing is dropping the cubes, this is still the same sign. Now you're going to build this really long trinomial. And so you take the term in the front, which is x, and square it. Put it in the front. Take the term in the back, which is 2, not a negative 2, it's a 2, and square it. Okay, 2 squared is 4, goes in the back. Front times the back is 2x. And after you build the pieces is when you come up with your plus and minus signs. So if this is a minus, this is the opposite. This is always positive. So can you see the difference between the difference of 2 cubes and the sum of 2 cubes? All right, I think you're doing okay. Now, let's look at 27x cubed minus 64. And the clue here is kind of this fact that somebody has a cube on here. So you go, well, all right, so I'm thinking maybe it's cubed. Is there anything in common to factor out between a 27 and a 64? No. So I'm going to show you the cubes. So what did you cube to get 27? 3. What did you cube to get 64? 4. Now I actually like 64. It's both, as a teacher, okay, it's both a square and a cube, so it's kind of fun. All right, now your teacher may like that too, so be aware that the 64 can be used as a square or a cube, so be sure you're using it appropriately. Then we're going to drop the cubes. And we're going to build this long trinomial. So once I drop the cubes, I only look right here. This is the only place I'm looking. So I take the term in the front and square it. 3x squared is 9x squared. I take the term in the back, which is 4, and square it, put it in the back. Front times the back goes in the middle. 3x times 4 is 12x. Right, so you build your pieces and then worry about your signs. So if the sign right here is a negative, this is the opposite. This is always positive. Now in your book somewhere, your teacher may have said something like a plus b times a squared. I have to build it because I don't actually have this memorized. And then we have these little formulas like this. All right, and they'll say a plus b is times a squared minus ab plus b squared, and a minus b times a squared plus ab plus b squared, but it's the same thing. Okay, so if you had a cubed plus b cubed, you drop the cubes. You take the term in the front, square it, and put it in the front. You take the term in the back, square it, and put it in the back. Front times the back goes in the middle. If this is a plus, this is a minus, this is always plus. Okay, so do you see how these formula that you have in your books, even if they're saying it in terms of x and y or a and b, it's the same thing we're doing. All right, so this is the answer to that. All right, how about 125x cubed plus 27? So let's see. Is there anything in common to factor out? I don't think so. So I'm going to try to figure out what I cubed to get the 125x cubed. I know I cubed an x. 5 cubed is 125, and 3 cubed is 27. So I drop the cubes, 5x, 3, and just copy this down. And now I'm going to build. I take the term in the front, which is 5x, and square it. And it goes in the front. Okay, 25x squared. I take the term in the back, which is 3, square it, put it in the back. Now to get the middle term, I go front times the back. 3 times 5x is 15x. And now I worry about my plus and minuses. If this is a plus, this is a minus, this is always a plus. Doing okay? Sure you are. All right, now there's a lot of rules to keep up with, which means you have to either memorize them in English or you memorize them in some sort of mathematical symbolic way, which is good either way. But you have to practice them until you can just say them over and over and over. All right, one time, very first time I was teaching, I think the first year I was teaching, it came to, I had them learning all these rules. Does it have anything in common to factor out? Does it have a lead coefficient of a 1 and is a trinomial? What multiplies in, adds the middle? And they could list all those rules about identifying them, what it was, but I never realized that they didn't learn the steps until I was talking to them and I was going, okay, so you tell me what to do, what are the steps? And they couldn't tell me. So it's not enough to identify what it is. You have to also memorize the steps that you're going to use to generate the factors. So be sure that you follow through with not just identifying what it is, but what do you do with each type? And there's a whole list of steps in some of them. Remember, I giving you one version of the list is attached in the description below, as are practice problems and solutions to the practice problems there, and links to the previous videos and the next videos that you need. All right. And of course, if you have questions, put them in the comments. All right. Now this one, this is where you go. I'm kind of leaning toward cubes because it has the x cubed on there, but I'm maybe not too comfortable with what 216 came from. And, I'm thinking, I don't know, it's 2 cubed is 8, so it's definitely not that. Okay. But if we had something like 5 cubed is actually up to 125 already, right? Maybe 6. Okay, 6 times 6 is 36. Okay, so 6 cubed is 36 times another 6, right? And this 6 times 30 is 100. Yeah, that would be it. Okay, so this is 6 cubed minus x cubed. So when you look at a number and you're going, oh, I don't know. Okay, don't give up and skip it and move on. Blank is definitely wrong. Take a minute and kind of go through some of your numbers. They grow really quickly, so it's not likely you're going to have to get up to, 12 cubed or something like that. So just slow down and give it some thought. All right, so it's 6 cubed minus x cubed. We don't care that the x is in the second place. We're going to do exactly what we learned before because it's going to work. All right, so we drop the cubes. Then we take the term that's in the front, which is 6 this time, square it, put it in the front. Take the term in the back, which is x, square it, put it in the back. Front times the back is 6x. If this is a minus, this is a plus, this is always a plus. Now, if that creeps you out, okay, you can change this around. That's the same thing. You can even change this around as long as the x stays negative. Any of these would be accurate. If this is just like, I'm just not buying into this, how do you get your brain to buy into something? You check it. Okay, so go over to the side somewhere and either use the vertical method or this repeated multiplication, where you're going through multiplying like this and show that it works out. And then you'll start going, okay, yeah, this really is not just some sort of magic. There really is a pattern to this. And then life will be much better, quicker if you will just follow through just once or twice when things make you kind of queasy. Okay. Now, all right. So let's look at this. I'm kind of leaning toward maybe the summer difference of cubes because of the a cubed and the b cubed. I'm not recognizing 32 as a cube. I'm not sure. Okay. So then you go, oh, wait. We forgot the step about, is there anything in common to factor out, right? Maybe if I factor something out, it would be more obvious if there's cubes in there. So let's try. Okay. They're both even, so let's try 2. Okay. 2 would go into it. Let's see. 32 divided by 2 is 16. That's a square, but I'm not looking for squares. And this would be 54. Now, this kind of makes you go, all right, but hey, we're not looking for squares. We're looking for cubes. All right. So, look, these are still even again. So maybe I could have gotten out of 4. Okay, so if I did 4, 32 divided by 4 is 8. It looks like a B. 8, a cubed. 4 goes into 108. Let's see, it goes in there twice, into 10, and then 7. Okay, that's a cube. All right, so this is actually 4 times 8a cubed plus 27b cubed. So sometimes you have to hunt around a little bit. That's okay. It's good for you. It grows all those brain connections I talk about all the time. All right, got to find something to smile about. Okay, so there you go. Now it actually looks like something I'm comfortable with. So now we're going to show the cubes. So you would have a 2a and cube it to get 8a cubed. And you'd have a 3b and you cube that to get 27b cubed, right? So don't forget the 4. Then you drop the cubes. I like to make my parentheses match and alternate. All right, you okay? All right. Then you take this term in the front, 2a, and you square it. Okay, that would be 4a squared. Then you take the term in the back and you square it. That would be 9b squared. Then you take the front times the back, 2a times 3b is 6ab. Okay. If this is a plus, this is a minus, this is always a plus. And you're done. All right. So that's the sum and difference of two cubes. Remember, there's some problems for you to practice in the description. There's a link to a worksheet. And in the worksheet, if you scroll past the first page, are all the solutions to the problems, because I don't want you to see the solutions right next to it. I want you to try them and then check the solutions that are start on the next page. All right. And then in the next video, we'll talk about perfect squares. Then we're going to talk about factoring by grouping. And then we're going to talk about the, used to be the trial and error method. Now they call it A times C, or, different other things. Magic method. I don't do the magic method. All right. So we will talk about those later.